Welcome. In this tutorial we will be using the elimination method to solve a system of linear equations. This is example number 3. And as you can see, I've already labeled each of the equations, equation 1 and equation 2. Next we will be inspecting the equations to see if there's an easy way to be able to eliminate one of the variables. Let's start with the x terms. Now imagine, is there an integer by which you can multiply the smaller x term and get what looks like the larger x term? Unfortunately, there is no such integer. So let's look at the y terms now. If you take a look at the smaller y term, is there a number, an integer, by which you can multiply the smaller y term and get what looks like the larger y term? Well, if you multiply 5y by 3, you would get positive 15y, which looks a lot like the negative 15y in the first equation, except with opposite signs. So let's do that. Let's multiply the bottom equation here by 3 and see what happens. So we're going to take equation 2 and multiply by 3. If we do that, we have to multiply every term by 3. So that's 2x times 3, which gives us 6x, plus 5y times 3 gives us 15y, which then equals 1 times 3, which is 3. This is a new equation, so let's label it as equation 3. Now, in order to help us visually eliminate the terms, let's just slide the first equation over. 5x minus 15y equals negative 14, so that the x terms are aligned as well as the y terms and the constants on the other side. Now, this is not a new equation. It's actually just equation number 1 copied over here. So let's just label it 1 once again. Now we're going to draw a line underneath these two equations and take a look. We notice that there's a negative 15y in the first equation and a positive 15y in the second equation. So if we add these two, then we would get 0. So let's do that. Let's add these two equations. In this case, we're adding equation 1 with equation 3. And when we do that, let's see what we get. Well, we would have to add then 5x with 6x, which gives us 11x, and then negative 15y plus positive 15y gives us 0, which means we've eliminated the y variable. And on the other side, negative 14 plus 3 will give us negative 11. So I'm just going to bring the 11x closer so we can see what to do next. In order to isolate for x, we need to divide both sides by 11. 11 divided by 11 gives us 1, and 1 times x is just x, which is equal to negative 11 over 11, which is negative 1. And that is the x coordinate for the solution. Now we just need the y coordinate. In order to be able to do that, we're going to be substituting the x value that we just found into one of the equations. Now, I like to use one of the original equations, not 1 or 2, and since equation 2 seems to have smaller numbers, I'm going to substitute into that equation. I'm just going to copy that equation out, equation number 2 down here, and we're going to be substituting x with negative 1. So everywhere we see an x, we're going to replace it with negative 1. And just copy out the rest of the equation. Now we have an equation with just y. in which case we can solve for y by simplifying. So let's simplify this side. 2 times negative 1 is negative 2. Copy the rest out. I want to isolate the y, so let's get rid of this negative 2 by adding 2 to both sides, which gets rid of the 2's on the left side, leaving just 5y is equal to 1 plus 2 is 3. Continuing on, we divide both sides by 5, which leaves us with just y equals 3 over 5. And this is the y coordinate for the solution. So let's conclude that the solution, or the point of intersection of these two straight lines, is the ordered pair x coordinate first, which is negative 1, then the y coordinate 3 over 5. And that is the answer to this question.